All right, we're going to look at how you can use some of the area of the triangle stuff we've done to find area of a regular polygon. Recall that a regular polygon from geometry is a shape where all the sides are congruent, and congruent means like the same amount. So if you have a pentagon is 5 sides. That means all 5 of these sides would be the same length. Hexagon's a 6-sided shape. If it's a regular one, all 6 sides are the same. What else is going to be true is if we divide these into triangles from the center, since all the sides are the same, that also means all these interior angles are going to be the same. And so we're going to be interested in finding those interior angles as well. It also means like all these exterior ones would be the same too, and that helps us find it out. So just some general guidelines, divide into triangles. We're going to find what those center angles are. We're going to find the area of the triangle, knowing that they're always isosceles, and then multiply by the total number of triangles to get the total area. So first one here, find the area of this regular hexagon where the perimeter is 480. Find its area. So if we know the whole perimeter, all the outsides added together is 480. A hexagon has 6 sides. We want to divide to start here. So we got 480 divided by 6, and that will give us 80. So each side here is 80 all the way around, and so on. We're going to now divide this into triangles. Okay, so we got 6 equal triangles. I'm going to focus on one in particular here and see what we have then. So if we have this one triangle, knowing that the outside length is 80, also knowing that these 2 sides are going to be congruent because that's isosceles, we want to now find some of the angles. Well, just like we divided the outsides, let's divide the angles by 6 as well. And these 6 interior angles should add up to 360. So 360 divided by 6 is 60. So that now what we know in our picture here is that all these angles are 60 all the way around. That also tells us right here that this angle would be 60. The 2 other angles here, because this is isosceles, should be the same. So if we subtract from 180 and divide by 2, that would give us those 2 angles. So 180 minus 60 actually is 120, and then 120 divided by 2 is 60. So this is actually an isosceles or equilateral triangle, not just an isosceles in this particular one. So all these sides are the same, meaning that's 80, that's 80 as well. How do we find the area of one of those? This one we could use that trig one, because we got an angle with 2 sides around it to find the area of one triangle. So let's use that one. We got half of 80 times 80 times sine 60. If you put that in your calculator, you can get the area of one of those. And then whatever that comes out to be, since we have a hexagon with 6 of them, the total area then would be 6 times whatever this above amount comes out to be, and we can get the area of the whole thing. Let's find out what that is. So if we do 0.5 times 80 times another 80 times sine 60, this will be the area of one triangle. So we get 2771.281. And now times that by 6 to get the total. So if we times it by 6, just hit times 6 on your calculator, we get the area of the whole thing. So the total area here comes out to be 16,627.688. And they didn't tell us what the units are, so we'll go units squared. Okay. For the next one, the perimeter of a regular hexagon is 240. Find its area. Why don't you pause the video and try this one and see what you get. All right, let's see how you did. So if you take the perimeter, divide by 6, all the sides are 40. If you take the 360 divided by 6, all these interior angles are 60, and they should be with any hexagon. Just looking at one then, kind of like the last problem we did, if you find those other two angles, they both are 62, meaning it's equilateral, all sides are the same. We can use our trig area one of half times 2 sides times sine of the included angle, and then because we got 6 triangles, let's times it all by 6, and you should have gotten this for the answer. All right, next let's try a pentagon one. So pentagon again means 5 sides here, and here they're saying the perimeter is 150. So start out similar again. Let's divide this by 5 though instead of 6, and here we're going to get that each side then ends up being 30. So all our sides here are 30 in length. It's going to get divided up here into 5 equal triangles here. Again, our middle angles should add up to 360, so let's divide that by 5 too. And if you do that, you're going to get 72 degrees. So all these angles are 72. Let's just draw out one of those now. So we know that bottom here is 30. We know these two sides have to be equal, and this angle is 72. We can find those other two angles now. So minus from 180. That's going to give us 108, and then divide that by 2. Because they got to be the same, and we get that they're 54 each, so both of these are 54. Now we got to do a little bit more investigating on this one because we don't have those other two sides right now. And the last one is easy because it's equilateral. Here it's not, but we can solve for one of those two sides by doing like law of sines, and we could get it because we have two opposite pairs of side and angle here. So if we want to find one of those sides, we could do sine of 72 over 30 equals one of these sides, however, whatever you want to call it, just call it x. Oops, sorry. The side would go on the bottom, x. And then the angle would be sine of 54. So if we solve that by doing cross multiplying and dividing, we can find x. So we'll get x sine of 72 equals 30 sine of 54. We can solve for x now by dividing. So do 30 sine 54 over sine 72, and we can find out what one of those sides are. So pop that in your calculator and you can get it. So we'll do that quick. You get 30 sine 54, close the angle up, divided by sine 72. And we see that one of those sides, or both of those sides actually, are about 25.52. So that's what both of these would be. Okay, so now to get the area of one of those, we can do that by using our trig area one. And on this one, if we're going to get the area of this pentagon, we're going to have 5 times the area of one of those triangles. So it would be 1/2. Our two sides here would be 30 and 25.52. And then sine of the included angle, which would be 54 degrees. So if we go through and find that out, we should be able to get it. And it looks like if you do that and put it in your calculator, you should get about this for the area. And it'd be in units. All right, octagon, same procedures the same, just changing the number of sides up again. So this one we know we got 8 sides. So if you get the perimeter here, you want to divide by 8. So we got 180 divided by 8. If you divide that out, we're going to get 22.5. So each of these sides is 22.5. We want to divide into 8 equal triangles. I'm just going to make this one on the bottom here. So we want to find that one, knowing these two are going to be the same and these two angles are the same. If you take the angles and divide by 8, we can find that top angle. So if we go 360 divided by 8, that's going to give us 45. So we know our top angle here is 45. Now we could use law of, or let's actually find those other 2 angles. So let's subtract from 180. It's going to be 135. And then we know there's 2 equal ones, so let's split that and by dividing it by 2. And both of those angles are going to be 67.5. So both of these angles are 67.5. So we can use that angle now with law of sines to find one of those other 2 sides, and then we can find the area of the whole thing. So let's go. Sine of the angle we know, 45, over the side opposite, which is 22.5, equals, and then we'll go sine of that angle we just found, 67.5, over, we can just call it x to find one of these other 2 sides. Cross, multiply, and divide, and you'll get that length of x. It should come out, if you're doing it right, to be about 29.4. And now we can get the area of this whole thing. So area of the whole thing, we got 8 equal triangles, and then we can use our area of our trig area equation again. This time I'm actually going to use, let's use that angle with these 2 sides, and they should be the same here. So we have 29.4 times another 29.4 with the included angle, which is 45 degrees. So put all that in your calculator and you'll get the area of the octagon. And it should come out to be about 2,444.78 units squared. This one is talking about parallelogram, another shape you could run into. So if you have a parallelogram, let's draw it out first. So there's our parallelogram, knowing these 2 sides are parallel, these 2 sides are parallel. It says the diagonals are a length of 8 and 14, and they meet at a 44-degree angle. Find the area of the parallelogram. So let's draw in those 2 diagonal lines. The length of that one is 8 here. And the length of this other one is 14. And what we know is that would meet in the middle and bisect each other. So we can get a little bit more specific here. If instead of listing the total length, let's list what it is on each side. So these 2 would be half of 8, which is 4 and 4. The other one would be half of 14. So these would be 7 and 7. And then it says that they meet at a 44-degree angle. 44 would have to be the acute angle, not the obtuse one here. So this would have to be 44, which also means the opposite angle would be 44. We can easily find that other angle if we want by subtracting from 180. So our other angle here would be 136, which means this angle is also 136. Find the area of the parallelogram. So I think we got all the information that we can right now from that, but we have side angle side going on right now. So we could use the area equation, trig area equation, and find this area of this triangle, which should be the same as that one. We could also use it to find this one, which should be the same as this one. So if we find the 2 triangles, double it, we should get the area of the whole thing. So you just have to do trig area twice here, and we can get it. So we got area equals, we'll find the one with the 44 first. So half of 4 times 7 times sine 44 would be the area of one of those. The other one would be area of half of 4 times 7 times sine of 136. And then we got 2 of each of those, so the area of the parallelogram would be 2 times both of those. And then added together. So I doubled both of them here, and we can find this. So now just type all this in your calculator, and you would get the area of the whole thing. And it should come out, if you're doing it right, to be about 38.9 units squared. Similar one here. This one wants us to find out or it gives us the diagonals and it gives us the angle they meet, but it is telling us something different. They don't want us to find the area on this one. They actually want us to find the perimeter. So let's do the same thing. Let's draw in those diagonals. And we know they bisect each other. So if one of them's 12, that means this is 6 and 6. And the other one's 20, so this would be 10 and 10. They meet at a 58 degree angle. So we got 58 here. That means this one's 58. That means we can find the other one by minusing from 180. So our other angle here is going to be 122. But if we want to find perimeter, that is the distance around the outside. We do know that whatever this length is, and these two are also the same. So if we can find both of them, we can get it. Here, instead of using one of those area ones, looks like we're going to have to use law of cosine to get that. So we want to do one of these missing sides. Let's just find this one first. Let's call it x. So that squared would be the other two sides squared, so 6 squared plus 10 squared minus 2 times those same two sides times cosine of the angle opposite, which would be 122. So we'd want to solve for that one. Okay, so let's do that quick on our calculator. You got 6 squared plus 10 squared, and then minus 2 times those same two sides, and then times cosine 122. And then that's x, that's what x squared equals, so then we need to square root that. So I copy pasted it. It looks like it's about 14.128. Okay, now we got to find what's this side. So I'm going to call that one y. So let's do the same thing with log cosines. Same two other sides, 6 squared and 10 squared. The only difference with this one is that now we're doing cosine of a different angle. It'd be 58. So we want to put that one in the calculator. One thing we could do here, since it's basically the same thing we typed in up here, let's copy and paste that. And then if you just scroll over and change the angle at the end, we should be able to get that here. So type in, oh, too far there, there we go. And we just want to change this to 58. So hit enter. And then again, that's what y squared is equal to. We want to square root that. So square root, copy, paste. And it's about 8.509. Okay, so now our total perimeter of this is going to be, we got 2 of the x's and 2 of the y's, so double both of them. And we can get our answer here. So our total perimeter is going to be approximately 2 times this answer plus 2 times our other answer up here. There we go. And hit enter. And it looks like the total perimeter is about 45.274. This would just be in units, not units squared, because it's not an area, it's a measurement around the outside. All right, final one. You could get one of these regular ones where it's inside of a circle, which is called inscribed, because the shape's inside the circle. What is the area of the shaded? Well, in these types of problems that you did before, you're going to have to find what's the area of the circle minus the area of the regular hexagon, and then the remaining should be our shaded in area there. So let's start with area of the circle. Would be pi r squared. That's one you should know. Our radius here, we don't quite know yet, so we're going to have to find that. Oh, sorry, no, I guess we are given it. Radius is 30, so we know if we draw in these amounts to the outside, that each of these is 30. So all the way around it should be 30 here. So this should be pi times 30 squared. We can put that in the calculator and come up with that amount. And it should be about 2,827.433. So that's the area of the circle. Now let's get the area of the hexagon. And once we know that, we can subtract them and get our answer here. So area of the hexagon is going to be 6 times the area of one of those triangles. Let's see if we can figure that out. We know that each of those lines are 30. So that's 30 and 30. We know from doing previous ones that in this, 360 divided by 6 is going to make that 60. These two angles are also the same though, so that's also 60, meaning this is equilateral. That's also going to be 30 down there. So we can get it using our trig area one, half of 30 times 30 times sine 60. So put that in your calculator. That'll give you the area of the hexagon, which is going to come out to be 2,338.269. And now to get the area of the shaded, we just want to subtract. So we want to take these two, subtract them, and we can get our answer. And so it should become about, area of shaded should be about 489.164. So most shaded ones, you're going to do some subtraction of the bigger shape minus the smaller shape.